The Sabrent Rocket 4 Plus is ruining my life. I don't want to install this because it's so fast that after I install this in my main PC, every other PC that I sit down at, I'm going to be angry. Thanks to our sponsor, Bob Keys. Now, Bob Keys has got Windows 10 Pro right now on sale with our coupon code TS25. You're not going to get 25, you're actually going to get 30% off until the end of December 15th, bringing Windows 10 Pro down to $12. Home is $13. And then you can get 2 copies of Windows 10 Pro for $21. And then you can also get Office for a very good deal. So be sure to use coupon code TS25 to get that 30% off. All the links are in the top of the description. And remember, it's still going to be 25% off on December 16th. But until the 15th, you're going to get 30% off. So head over to bobkeys.com and use our coupon code. So like I said in the beginning, this is insanely fast. And I actually, that was... After I did the test, that was literally the first thing I thought was like, okay, after I go to any other computer, my laptop, another computer, a friend's computer or something like that, and I sit down, I'm going to be sitting there going like, what's wrong with this? What's wrong with this? It didn't do what I told it to do before I finished telling it what to do. What's wrong with your computer? So let's go through the specifications in this. This is the 2 terabyte version from Sabrent. Good old Rocket 4 Plus. The 4 came out, I think it was in June or something. But the Plus, oh my. This is PCI Express 4x4. Why is it so fast? I heard somebody ask. Well, this Phison controller doesn't mess around. Also, PCI Express 4x4. Make sure your motherboard can handle it. This motherboard could barely handle it. It couldn't quite get to the speeds that they advertised, but I'm still happy with what it got, and you'll see that in a minute when I show you the benchmarks. We get the Phison P55018-E18-41 controller on this. I mean, those are numbers that I know mean a lot to somebody. There's our NAND flash. Look at this nice little cutout on the website. I didn't have to rip the NAND flash off of mine. I can just show you what they did on their website. Isn't that beautiful? And then we've got our caching system, which is an external caching system for DDR4. That might be what it was. And here's what they advertise on the read and the writes. The 4 terabyte version's not out yet. Got my eyes looking for that thing. So the big difference between this one and the 1 terabyte version is going to be your sequential write speeds are going to be a little bit higher, like 5,300 versus 6,600 advertised here. And then the max read speed is going to be 7,000 versus 7,100 here. So the read is going to be very similar. The write, I think, for a lot of people is going to be very similar too. But get the IOPS. Random 4Ks on the 1 terabyte, 350,000 versus 650,000 IOPS here. Of course, the bigger drives, you get a little bit of an advantage there. And then for the writes, both of them are at 700,000 IOPS advertised again. Now, this version that I got came without a cooling unit of any kind or a heatsink. And I'll show you the temperatures in just a second, but it wasn't that big of a deal in my opinion. And then go ahead and go online and register this because you're going to get a 5-year warranty. They did their test on an 8-core. I've actually got the 12-core Ryzen 3900 in here. The Asus X570 Hero motherboard. We've got 32 gigabytes of guile memory running at 3200 megahertz. And then, of course, we have our PCI Express Gen 4x4 slot on this motherboard. So that's what I'm going to test with. Now, there's the heatsink you can get if you wanted it right there. All right, the only other Gen 3x4 M.2 that I have are Corsair and the previous Sabrent, but they're both 1 terabyte. So I don't have a real contender here that's going to show anything close to the speeds that I'm going to show you with this one. But just for the comparison's sake, we'll use the MP600 from Corsair. Corsair is going to be on the left side of the screen, and the Sabrent Rocket 4 Plus is on the right side of the screen. So we have some interesting results here. Like the read speed is quite a bit higher, like 1,000 megabytes higher with the Sabrent, but the write speed has a slight edge over there on the Corsair, but overall kind of goes back and forth between the read and the write on the 2 of these drives. All right, Atto is really the test that everyone likes to use to show the muscle of the drive. The fastest that I could get on this motherboard did not reach that 7,000 megabytes per second, but as you can see right here, we got right around 6,000, a little over 6,000 megabytes per second right here in the middle. A lot higher than we got with the Corsair, but again, you know, this is a brand new, fancier drive. So I'm not sure exactly where the bottleneck is in this system. Updated the BIOS, made sure all that was fresh, tried this, test a few different times. But I did notice that once I turned my Q depth up to 10 rather than 4, it did help. I'm going to try it again at 16 and see how that works later. And take a look at Crystal Disk Mark. This one got a little higher than Atto, which Atto usually is the one that gets the highest. It's got that compressed just data going crazy. This one got as high as 6,375.87. So pretty high right there on that one. Pretty interesting how these drives have different characteristics depending on what we're testing here. But overall, the Sabrent is quite a bit faster. If you bring up the performance test here, you can see this computer. It's in the 98th percentile. I want to know what's faster. Like it says right here, 98th percentile. What's the other 2%? Because I haven't seen it. I'm sure it's something somewhere. I don't know. But there you can see how it stacks up against some of the others at the top of the list. And lastly, let's talk about the temperatures. So when we're just hanging out in the room and idle, it would sort of fluctuate between 33 and 35, depending on if I was doing anything with the computer. But mostly it just hung out around 35 degrees Celsius. At full load, I did what I ended up doing here was I did this test several times. You notice with the Q depth, it's a little lower, but I did this test several times in a row and then took a screenshot after it finished like the third or fourth test. And you can see it got up to 59C, which in my opinion is not too bad. And I'm not using the built-in heat spreader or the heat shield or anything like that came with this Asus motherboard. I'm not using that. I just wanted to use it as is, as it comes out of the box, without any extra, heat dissipation or heat sinks or anything like that. So you can get a heat sink and keep it even cooler. But even without the heatsink, you're going to get the 5-year warranty. I'm slightly sad that I didn't get the 7000 on the read. I'm not sure what's up with that. I'm going to try this on an ASRock motherboard as well. Later on, I'm going to be using this in my build because it's so freaking fast. I'm not sure if I'll put my OS on this or if it'll be my secondary drive. But I've got one of the Sabrent 8TB drives for my secondaries. Maybe this will be the primary. I don't know. It is so fast that I know I'm going to get spoiled. Like it's that kind of speed that we're talking about right here. And then if you're using this in PCI Express Gen 3, an older motherboard, you're going to get 3500 to 3600 maybe on the read and write. It's going to completely just saturate your PCI Express Gen 3x4. All those lanes will be full of data. I don't know if it's worth it, but check the prices on this versus other Gen 3x4. But one of the nice things about this is even if you get it now, this will last for a few years. So if you get it now and you build a new computer that does have PCI Express 4x4, then you install it, you'll be like, oh, it's like I just got an upgrade. So it might even be worth grabbing even if you have a PCI Express Gen 3x4. I was looking around online because I felt like, my take on this was maybe a little glowing, maybe a little too happy. And it's funny, like, over on premium builds, their conclusion was, what's the best between this and the Samsung 980 Pro? Who's the winner? The customer, because we have such great competition nowadays that it's good for you. So yeah, great. But they also did recommend the Sabrent even over the Samsung. So it's a hell of a drive. We'll give it -1 point because I couldn't get it up to their advertised speeds on this Asus, even if it's my fault and there's something in here that's creating a bottleneck. I don't know. I've even got my Infinity Fabric in sync. Could it be the CPU, that 12 cores? I don't know. I'll mess around with it, but it's already the fastest M.2 that I've ever tested, so there's that. That's the end of the video. Are you going to get one of these? Which one are you going to get? The 1 terabyte, the 2 terabyte, the 4 terabyte? Are you going to get one of the 8 terabyte 3x4s like I've got as well? Let me know. It's the era of super fast M.2. One more thing before I leave. Someone, while I was streaming tonight at my stream on Twitch, Midnight Dojo, working on games and playing games, twitch.tv, Midnight Dojo. Anyway, I was streaming tonight and someone said, is this going to matter at all for gaming? And the answer is, not yet, but soon. Because Unreal Engine 5 and also the PlayStation is pushing this technology that will allow streaming straight from the M.2 if it's fast enough. And that means that all the textures and stuff in the world that you see will be coming from the M.2 straight into your GPU, straight into your eyeballs. And that's going to bypass having to load everything into RAM or into video memory. And if you're moving around into an area right now, especially in like a big open world game, you'll notice that every once in a while when another area is loading, there's a stutter or there's a hitch. And with something like this, once the new game starts to take advantage of it with Unreal Engine 5 and stuff in the future that's coming out, that'll all be streamed straight from here, so it's way faster than having to go to a legacy hard drive, pull that data, put it into video memory, put it into RAM, and then have it stream into you as you get there, and then there'll be a stutter. You won't see that anymore. You won't have to have loading crannies, like when you're in a world and you're trying to go to the next area, but you have to go through a tiny little bridge or through like a crevasse. And then when you come out on the other side, you're like, that gave the system enough time to load. We won't have to do that anymore. So it'll be really good for game developers, but also good for gamers. But this is all stuff that's going to happen mostly in the future as Unreal Engine 5 and other engines start to work with really fast hard drives. It's not a drive. There's nothing moving in here. It's just an M.2. I don't know why we call them drives still. SSD, solid disk drive. Nothing's driving in there. It's just solid state memory just sitting there. That's the end of the video. I'm done. If you don't buy a t-shirt, I'll pull your ears all the way down to the floor. And then you can tell everybody that you used to have plugs, but you were in an accident. And I'll just pull your ears really, really far if you don't go buy a t-shirt and a mouse on epicpants.com. Marketing, goodbye.